Today's topic is an exciting one. This is really where you are going to start seeing the true power of a GIS to analyze spatial parts of data. So we're going to perform a number of different analyses. They're very simple, but these are the most common operations you would do in a GIS. So this is fundamental or basic spatial analysis. So anytime you look at geographic information, your eyes and brain tend to start analyzing it themselves. So here in the upper left corner, this is a map of pirate attacks near the Persian Gulf and in the Indian Ocean, and here's a map globally. So right away, what does your brain tend to do? I know when I see this, my brain says, well, what's going on right here in this Gulf? Here's some cluster of points. This seems like a lot of pirate activity going on. Out here in the open waters, not so much. As we look globally, again, we see this high density through the Indian and Pacific Oceans here, some across here, but not so much in other areas. Or as we look at this eruption, this is an elevation model of Mount St. Helens before and after, we automatically notice differences between the two things. And for me with the background in geology, I see, well, this exploded out and probably erupted off towards the northeast. So our brain starts putting together the pieces for us. But what we want to do is be a little more rigorous and formal in what we do. So spatial analysis are these techniques to formalize what your brain tries to do when it looks at spatial data. So spatial analysis is some process that looks at locations of things, looks at their attributes, and then analyzes relationships in those attributes and locations in spatial data. Right? That's the key thing we do in a GIS. We look at data that has a geographic or spatial component. And the reason we're doing this is we want to address a question or gain some new information or useful knowledge here. So spatial analysis is all about answering questions, solving problems. When we perform spatial analysis, it's either going to extract information out of your existing data, or it's going to create new information from it. So oftentimes it will extract some subset of your data or may output an entirely new data set here. But the key thing to take away here, spatial analysis, are these techniques for addressing questions from spatial data sets. So here are some examples of spatial questions, right? What is inside a neighborhood? What features live within some boundary? What is near a treatment plant? Are there concentrations in some pollutant or some chemical over space or even time? Where do crimes spike over time? We can look at spatial data. We can also look at temporal relationships and see how patterns change through time. Why diseases occur where they do, tracking the chart of infectious diseases, or how do we estimate values for food accessibility, where we have some model of various spatial parameters to characterize, say, something like accessibility to food. Or what is a suitable location for a new cell phone tower? Again, we have some model that looks at different spatial data sets to make an assessment whether a location is suitable or unsuitable. So we'll attempt to answer some of these very basic questions, but we're going to use a few sets of tools. The first one are extraction tools, such as the Spatial Query or the CLIP. And these answer questions of a type, what is a geographic subset of a data set? So they extract information out of existing data to identify some subset. Overlay tools are those that answer the question, what's on top of what? So we know a GIS stores our data in these thematic layers that all live one on top of another. Overlay looks down through this stack of maps to see what things are on top of each other in different ways. The last one are proximity tools. So quantifying how near or how far features are from one another. So we'll take a look at the buffer tool, which identifies regions a certain distance from a feature, as well as near and point distance tools, which give you a measure of distance between points and other features. I'll just put this all up here. When you perform a spatial analysis, there's a general workflow here. Generally, you're framing the question. You know, what is the problem I'm attempting to solve? What's the scope of that problem? What, both spatially and temporally, what's the scope of the problem, and what data do I need to answer that? And so exploring our data, is the data I have suitable, both in its distribution or its accuracy, or its spatial scale to answer that question. And then we choose our method. So oftentimes we're looking at the literature or standard workflows for this. Sometimes in research, we're assessing our own methods, but we're going to review the question, see is our data suitable, and a method that can address that question. And then we perform our analysis. We'll take a look into the ARC toolbox today, where there are these geoprocessing tools and scripts. There's also automated methods in ArcGIS for doing this sort of stuff. Hopefully next week we'll do a little bit in Model Builder, which is like a visual programming language where you construct workflows as a flow chart, or you can write Python scripts that fully automate any processing workflow. So ArcGIS runs on a Python library. You can call that directly. So finally, when you have output, you have results, you want to examine them. Do they look accurate? Are they what you expect? And if important to you, statistics, look at the statistical information. So in 2 weeks, we'll have an introduction to spatial statistics. So I've said this term a couple times now, geoprocessing or spatial geoprocessing. This is a terminology that's used quite frequently when you're performing spatial analysis. And this is when you're going to apply spatial data sets or apply GIS operations to spatial data sets and their attributes. So generally, we're going to have one or more independent processing steps that are all linked together sequentially through some workflow. So the challenge here is knowing in what order to apply these operations so that you get the correct output. So geoprocessing is linking all these different operations together. For instance, you may be trying to do a suitability model where you're trying to locate a feature using input elevation data to give you information about the terrain, soil type. Certain soils may have better engineering attributes than others, and then vegetation. Maybe vegetation plays into this somehow. Our geoprocessing operations are shown here in red, right? We could calculate the slope of the land and the aspect, the way it faces. We could select particular soil types out of our soil and vegetation, and then we get output data sets. And then we may take a union on these, perform another operation that gives us our output data. So this whole process would be geoprocessing. So I just want you to be familiar with that term as you see it come up or as I refer to it. Questions so far? Okay, so as we perform these things, spatial analysis and geoprocessing in ArcGIS, you often grab tools that are in the ARC toolbox. So on the Introduction to GIS workshop, we talked about how there's ARC Catalog and ARC Map that are the big components of this software package. ARC Toolbox lives in the background of both of them. So this has all sorts of different processing tools and scripts. There are also things called extensions, which are essentially add-ons to the software that add more tools to it. And next week, we'll take a look at the Spatial Analyst extension. So the ARC Toolbox has within it all of these different tool sets that are related categorically to one another. Extensions need to be turned on, and we'll see how to do this next week. But if you're ever running, say, a Spatial Analyst tool and it tells you you don't have a license, you probably forgot to enable that extension. What I love to use, because I'm lazy and I don't like digging through our toolbox, is the find tool, or the search, rather, where you can search for the name of a tool set and it will help you find it without clicking through the ARC toolbox. So you can access that anytime by hitting Control and F on the keyboard. So the first example of geoprocessing tools we'll work with are these extraction tools. So these are used to select some portion of your data or clip part of your data to a specific boundary or split the data into several component data sets. So the first thing we're going to do is use this clip tool, which is one of our extraction tools. So this is essentially a cookie cutter for your data, where your existing data set is the dough, and you want to clip out some small portion of it. So there's a change in geography here, but not in the attributes. So any of the attributes that are in the source data will be in that resulting clipped data set. Generally, what we want to do here is clip out your data to a specific area of interest. You may get data that cover the entire United States, and you're only interested in Pickens County. So you may just want to clip and cut out your data to Pickens County, so you don't have to wait for it to load every time, or calculate information for Washington State that's not relevant to your area of interest. So this works with, you can clip points, lines, or polygons. You do need to have some sort of polygon layer to clip those features with that acts as your cookie cutter here. So our example, our input points would be W, X, Y, and Z. And our clipping area is the circle, so our result is we'll have new points 1 and 2, and they'll retain the attributes W and Y that they originally had. So we're changing just our geography, but not our attributes. That makes sense? So an example in practice might be this area along the river where a central business district is shown by this, this black line, and these brown lines are all contour lines. They represent topography. So if we are only interested in the elevation contour lines for the central business district, we may clip that area. So our topography is our cookie dough, right? Everything in GIS is food. And then our central business district becomes our cookie cutter, with our result is that it will clip and discard anything outside the boundary. So we have a variety of data for South Carolina as well as the United States that we're going to look at today. Looks like I have a typo. This should say roads and clip boundary. But anyway, we're going to clip highway data for all of the US to South Carolina using a polygon for that South Carolina border. So this will be our first exercise for today. So let's go ahead and open ARC catalog first. Let's take a look at the data, preview our data that we'll be using today during the workshop. So I'm going to go to my start window, to all programs, to the ArcGIS folder, and then click on ARC Catalog 10.5.1. So we'll use ARC Catalog to preview our data. What's the first thing I need to do when I open ArcGIS? I'm going to work with some new data I've downloaded. What's my first step?
And you have folder connections?
Yes, right? We need to set up a folder connection. So on our machines, we have 2 by default. If you're using the same computer you've used in the past, you might have more than that. But we need to connect to that location where our data are stored. So how did I do that? The folder with the plus sign. Yep, here's my connect to folder button here on my menu, or I can right click in my catalog tree on my folder connections and select connect to folder. Did everybody know that answer before? You're just too shy to say so. Okay. You know, I'll
access the catalog through our map. Is there a reason why we go to catalog?
So here we're going to actually preview data before we even open it in a map document. So when you add data to ArcMap, it takes longer to display, especially if there are multiple layers in your map. Here we just want to look at the data before opening it. So, so we're going to preview data. So we need to connect to the folder. I'll go to computer, click here, click on data to D, and select the basic spatial analysis folder. Again, those of you connected remotely, this folder connection will be the location you've extracted the basic spatial analysis data. So here's my folder connection. I see what? What do you see living in the folder? What are they? Some geodatabases. Yep, some soup cans, right? Basic spatial analysis results, spatial analysis problems. There's a .mxd. That ArcMap document will work out of. We'll open that in a few minutes. And then these things, .lyr, these are layer files. So all the data we'll work with today are in basic spatial analysis geodatabase. So you can see there's airports, bridges, counties. I'll switch to my preview tab here and just take a look. So here's airports, bridges. That looks like South Carolina. Charleston County, counties, groceries. See how long this highways US feature class takes to load already. But you can see its extent is all over the United States, including Alaska and Hawaii. Hurricane shelters, schools, South Carolina polygon, and these storm surge zones. So what do we want to know about our data anytime we start a project? Especially if we want to analyze things about it, maybe quantify distance as we go. What do we want to check for our data? Check the coordinate system, right? So we want to know what coordinate system all of our data are in. So first we want to know if it's geographic or if it's projected, and then we want to know if they're in the same projection or not. So where are we going to go to find that out? Any guesses? In the properties, right? So if we go to a feature class, for instance, airports up here at the top, right click that feature class and then click on properties. We'll get all sorts of information. What we want to do is go to that XY coordinate system tab, and that will tell us which coordinate system our data are in. So which one is listed here? I see NAD 1983, 2011. So that's the datum. I see state plane, South Carolina. So this is a South Carolina state plane system. And what are the units of this system? Meters. Where did you see that?
Far right.
At the far right at the end of the name, yep. Or down here, linear unit is meter. So what we want to do is, state plane is a great system to use for data at that state level. We want to see what other coordinate systems are being used for our data. So take a look through those feature classes and tell me if you see any other coordinate systems in use and which feature class it is. Highways US. Which coordinate system is in use? So before I even look, I'm just viewing my data, and I notice the top border of the United States here in my preview is straight across, which tells me already these are probably in latitude, longitude coordinates, or a geographic coordinate system. So if I right-click Highways US and look at the properties, I see, yep, WGS 1984, the GCS in front of its name indicates it's geographic coordinates and its angular unit of degrees. Any others? Is that it? Look good otherwise? So we have most of our data is in the South Carolina State Plain. There's this one that's highways that is not. So what we're going to do is project these data into that state plane coordinate system. And to do that, we're going to use the project tool. So that'll be the first tool we'll run today. I'm going to click here on the toolbox icon here near the top of the screen. That red toolbox, click and open the ARC toolbox. It may take a minute or so to load.
Give you a working circle or anything to let you know it's loading.
In ArcMap, it would give us the rotating globe to let us know here. I just know because I haven't seen it open yet. And if I move my mouse around, it doesn't do anything. There it is. So here's my ARC toolbox. I'm going to dock it. Mine came up floating. I'm going to drag and drop and dock it here on the right side of the screen. So does everybody have that open? Got the toolbox open. We're going to go through our data management tools. Let's expand that toolbox for data management tools. And then we want the projections and transformations tool set and expand that. And there is the project tool. So again, I expanded my data management tools, my projections and transformations tool set, and then I'm going to double click on project to open it. And what I like to do is down here near the bottom right corner is this show help. I like to leave that open because it generally shows you what the tool does, and it also gives you information about every parameter in a tool to help you know what it's looking for. So our input data set or feature class is going to be our Highways US feature class. So I'm going to click this browse icon, that folder. Click at the top under Look In, go to my Basic Spatial Analysis folder. Double click on my Basic Spatial Analysis geodatabase. And then click on Highways US feature class and click Add. And note it reads in the coordinate system, WGS 1984. I'll save my output. I'll click here on this folder icon. And mine automatically went to this results.gdb. If yours did not, click at the top where it says Look In, go to the Basic Spatial Analysis folder, and double click on results.gdb. We're just going to store all the outputs from today in a different geodatabase. And so I'm going to call this highways _ US _ PRJ so that I know this is going to be a projected data set. And then I'll click save. And then we need to tell it the output coordinate system. Yep.
I tried to use highways as input data set, but it says something like click arrow or line. But I don't have any other highway data set.
So, yep, so you just need to click on basic spatial. Yeah, we need to go inside the geodatabase because it's kind of like a folder.
Let's see.
So does anybody else need to see that, the steps again? Which part? From the start?
On the second.
This, the output? Sure. So I browsed, clicked that folder. I went to my D basic spatial analysis folder connection, and then double click my results geodatabase to go into it. And I'm saving my output as highways underscore US underscore PRJ. And then click save.
There's images on the right input to output. Are those supposed to show up automatically?
Oh, and click on it. They'll only show up before you click on it. So once you use your mouse.
Oh, way over here. It's so tiny. Okay. I can't see anything. Like I need better glasses or something. My new person is gonna make her help me. Without feeling bad about it.
Okay, so we still need to specify our output coordinate system. This little green dot in the tools letting me know it needs more information.
Could you please repeat the output data set?
Sure. So I clicked my browse button here. I went to my basic spatial analysis folder, double click my results geodatabase, and I'm going to save it in there as highways underscore US underscore PRJ. Then save. So our output coordinate system, we can click this button and we're going to navigate through this menu. First, it's a projected coordinate system, so we'll expand that folder. It's a state plane system, we'll expand that folder. Our datum is NAD 1983-2011 meters, the third one from the top. So we'll expand that. And then we're going to scroll down the list till we find South Carolina.
Yes.
FIPS is the Federal Identification. I'm going to get it wrong. I should just Google it. Federal Information Processing Standards Code. They are assigned for things like counties, states, census tracts, potentially blocks and block groups. They just differentiate one region from another. Does everybody find that state plane coordinate system? All right, then let's click OK and click OK again. And there are a lot of features in that Highways US data set, so this may take a little bit of time to process. Okay, mine completed. So now if I go in my catalog tree, expand my results geodatabase, and then click on that new feature class, I should see it now looks a lot different because now it lives in the state plane coordinates, projected coordinate system. Look good to everyone? It's a software that when it's thinking doesn't like you. No, it's right here. So it is still thinking, but that's okay. We're going to close our catalog and stuff. Okay, so let's open ArcMap. We're finished in Arc Catalog for now, but let's open ArcMap. I'll go to my Start menu, to All Programs, to my ArcGIS folder and click ArcMap 10.5.1. And I'm going to close Arc Catalog, the program. So we previewed our data. We've seen our Highways US feature class. It's actually our Highways US projected feature class that we're going to clip. We have that polygon representing the border of South Carolina. We're going to use that to clip out the highways just for South Carolina using the clip tool. And of course, when I log on this machine earlier in the day, this program loads really, really fast. Need it to go quickly, it won't. But if I get this Business Analyst Desktop Message Center, I'll go ahead and close that. Here's my ArcMap. So we're going to open a map document. If I go to my catalog, I may need to show the Arc catalog by clicking this button on the top. I'm going to go to my Basic Spatial Analysis folder connection, expand that, wait for it. And then I'll double click to open this Basic Spatial Analysis tutorial.mxt. And if you get a notification from Business Analyst, go ahead and close that one as well.
What are we doing?
It's this Basic Spatial Analysis tutorial.mxt.
Should not do hardware.
Right. If you get a notification about hardware acceleration, click no. So everyone has the map open. So this map has 4 of something that is new for us at this point. What does it have 4 of in it? It has more than 4 layers, but I'm going to minimize something. What were my American Craft single stack cheddar slices, whatever? What are these icons over here? These are data frames, right? So remember at the first workshop I said we can have multiple data frames in a map. Each one of these can have data added to it to construct maps that are independent of one another but live in the same map document. So here I have an extraction, data frame, overlay, proximity, and spatial join. So a different data frame for each set of tools we'll use. So here we're going to work in our extraction tools data frame. We need to add that highways US PRJ or projected data set to the data frame. And then we're going to clip it out. So I'll go to my results geodatabase, expand that, and drag and drop that feature class into the map. And I'll turn off my highways US layer that's already in the data frame. And so my highways show up with green lines. Yours may be a different color. But we want to clip and cut out these highways just to South Carolina, so that as I zoom in and out, it doesn't have to draw those roads for all of the United States, which takes forever.
How about my maps first?
Okay, so we want to clip these out. Our most common geoprocessing operations are here in the geoprocessing menu at the top of the screen. So we can click on geoprocessing and then click clip to open that tool. So our input features, this is the cookie dough. So this is going to be our highways US projected layer. I'll click this triangle here to open my drop-down menu and grab a data set from the data frame. I'll click highways US PRJ. And my clip features, I'll also grab from the data frame. It's going to be that South Carolina border. And my output feature class, I'm going to browse, click that browse icon here. I'll save it in my results geodatabase and just call it highways_SC. And then click save. Once you've set those, you can click OK and run the tool. I'll click close to close my dialog here. And I'll turn off my highways US layer. Let's see, I have a bookmark for South Carolina, so I'll go to that. And I can see now this new highways features class stops right at the border. So I turned off my highways US PRJ layer. So I can see just that output.
You have to just no, just have a new one.
I don't know how I got over there.
Thank you. Like, yeah.
Yeah, like I saw music. So that's, I don't know why we have like that great highways you like. That's that
Yeah. Which is why they but it's so many good software engineers that like why just have to make just like less.
I sorted it out. I had extra layers of highlights for review.
These are catalog is 798. So mine was just frozen for at least 2 minutes. I'll just watch it with you. There's no results.
Yours, I think you saved.
Then I drag it over like this. That's really good.
Features is the South Carolina border. Here, 8%. You guys are like, this. You say this
There's the tool. I can find down this frozen too.
Okay, it's Geospatial.
I can teach that. I know how to do that. Okay. Alright, so I'm gonna drop the process of investment and already grab the very top one.
Anyway, now I'm trying to redo it.
And I can go to the next line and do it and grab some.
Okay.
Tool already running.
And then if you can save it as like.
And then what you do is then I said left there, or just right here, and then do this, and then try to do the whole thing again. And even though it's gone, and catalog view, it's just.
One thing I did. And just so that we I don't learn how.
Would that go away automatically once I?
I don't show it for like 5 minutes. So I'm not sure
That
about
was
this.
good. So that's refresh.
Some of those are so challenging. Because I didn't really yeah. Every single case. Yeah, it's just. I was struggling to do this once again. But it's actually quite interesting. It's really interesting, but it's like this kind of
Okay, so it's just refreshing, letting it do its thing. Okay, perfect, thank you.
When we have these, will it show me things from all of these different things at the same time?
No, only one.
Okay, and is that just, how do you do that?
Yep. All right. So we've clipped our data. So how hard was that on a scale of 1 to 10? 100. So, all right. So we've clipped out our streets to our area of interest. The next extraction tool we're going to look at is a spatial query. So last workshop, we did tabular queries, right? So we looked at the attribute tables and learned how to build a statement that would select some subset of our data where some condition or set of conditions are true. Right? So we looked at TRI facilities. We maybe selected those in South Carolina and those that were releasing column using a tabular query. A spatial query will also select some subset of your data, but here it's going to use locational information and relationships. So it's either going to select by intersections of things that overlap one another or share a common part, things that are adjacent or within some that touch each other, proximity features that are within a distance, or containment, so things that are within the boundaries of another. So we'll use the select by location tool. You can also do things like select by a graphic, or use the select tool where you draw a region yourself. So just to see what these sorts of spatial querying relationships look like, intersection, this is where they have a common part. So if I was going to select from my line feature class where it intersected my green polygon, it's going to select this part because there's some overlapping portion with that green polygon. So again, our selected features will show up in that cyan color by default. For features that are adjacent, if I select from my red polygon layer, a feature that's adjacent to the green, it's going to select just this polygon and not the other because they do not touch. This red polygon does not touch the green one. Containment, if I again select from red where it's contained by green, it would select this portion but not the other. So the select by location dialog looks an awful lot like the select by attributes, but here we specify, we can do the same things we did before, select features or deselect features, but here we're going to specify the relationship between the two that we're going to use. So there's lots of different options, right? Intersect or within a distance of, contain, have their centroid in, are crossed by the outline of. So there's a lot of different spatial relationships here. And the options will change based on the geography or geometry of your inputs. You can also apply buffers or a search distance. So you could find things that are completely within a boundary and then also add a search distance to it within a mile of that boundary as well. So you can expand on your spatial query here. So what we're going to do is try to identify a subset of our hurricane shelters data. So an emergency manager is interested here in Charleston County, and they want to know the capacity of shelters that are, let's see, just in Charleston County and within half mile of a grocery or some food source. So within our hurricane shelters features class is a capacity attribute. We can sum and add up that number, but we only want to add up the values where they're within Charleston County and within a half mile of a grocery. So we'll use our hurricane shelters feature class, groceries feature class, and counties feature classes. So let's switch back over to ArcMap. So where am I going to go, do you think, if I want to set up a new selection query? The selection menu, right up here at the top, selection menu, rather than select by attributes, we'll select by location. So our selection method is select features from, and our target layer is going to be our hurricane shelters. So we'll check the box next to that. Our source layer is our other layer we're considering. So first, what we're going to do is select those that are within Charleston County. So my source layer is going to be Charleston County. And then I need to choose my spatial selection method. So I'll expand that menu. I want you all to take a look through it and determine which one of these you want to try to select just the hurricane shelters in Charleston County. And when you think you know, call it out. Get some suggestions. Can you say it again? Are within the source layer feature. So if you have a line segment, is it partially within or is it completely within?
Oh, so like if a hurricane shelter's on the border of the polygon?
I would say if a segment of highway is within, is it entirely within Charleston County or is it at least partially?
But since we're asking, probably the shelters are points.
Yes, the shelters are points.
Within a polygon, so does it really matter which is within or completely within?
Shouldn't.
Okay.
And I'm going to run what I had by default was intersect the source layer feature. And then I'll click apply. And I can see some of them show up blue. So how many of our hurricane shelters are within Charleston County? Where do I want to go to find out? Yep, down here at the bottom says 15 shelters. Everybody got that?
No.
Oh, down here in the lower left corner. Oh, mine went away. I don't know what happened to it. We could also open the attribute table of our hurricane shelter. So right click that layer, click open attribute table. And then I see 15 out of 288 are selected. So now we want to apply another selection tool to our data. So our selection method at the top of this dialog will change. We're not going to select features from, we're going to select from currently selected features in. And we're still selecting from hurricane shelters, but now our source layer will change. Our source layer is going to be groceries. And now we are going to choose our within a distance of the source layer feature. And we need to specify what that distance is here on the bottom. And so we'll change our units to miles in that drop down and change, mine came up to 0.4. I'm going to type 0.5 within a half a mile. Then apply that selection and tell me how many you get. Click apply. How many did you get?
30.
How many?
30.
30? How many? 4? 3. I got 3.
Okay, way more than I'm supposed to.
Okay, so I'm going to clear my selected features up here at the top. So click on clear selected features. And I'll just repeat that process. So first I'm going to select features from hurricane shelters. My source layer will be the Charleston County from my dropdown. And my spatial selection method will be intersect the source layer feature. And I'll uncheck the box to apply a search distance. Click apply. Does everybody get 15? All right. So the next I'm going to not select features from, but select from the currently selected features in at the top. So we're still going to be selecting from hurricane shelters, but now our source layer will change and be groceries. And my spatial selection method will be our within a distance that I'll set to 0.5 miles and then click apply.
Selected the rock source.
Thank you. Within a half mile of itself. I should select all of them. Okay, and then I get 3. Did everybody get 3? So what's the capacity of the shelters? How many? Oh, what's the capacity of those shelters? How many people can we house in there in the event of a hurricane? How can I know exactly how many?
Isn't it on the table?
From our table, but quickly I can right click on that capacity from my attribute table, click on statistics, and then generate those summary statistics right away. So you were close, but the exact number is going to be 1,177. Questions? How do you feel about spatial queries?
What are the,
There's in the options like spatial selection method. There's these ones that are the same, but they say like Clemson.
Oh, I would have to look that up. It's some other way of evaluating a containment relationship. Yeah, I myself don't know what the Clementini is referring to. Any other questions? All right. So let's continue on our spatial analysis here. So we've performed some extraction, we've clicked things, and we've selected a subset using location information. The next thing we'll look at then is overlay analysis. And this is very, very powerful, and it's one of the most common and here's critical functions you can perform in a GIS. So here we're going to take different layers and we're going to combine information from these layers in different ways. So you can think of this as stacking and merging of spatial data sets together, or we can do things like erase data using one data set to erase another, or modify features from multiple data sets. But the key here is where these data sets are coincident with one another geographically. The first tool we'll look at is the intersection tool. And so what this does is it takes a set of layers and it's going to output a combination of the geometry and the attributes that's common to all of the input layers. Basically everything that intersects or overlays one another. So these are going to be the areas occupied by the intersection of input features. We can intersect any vector data together, points, lines, and polygons. The output goes to the lowest dimension. So if you intersect polygons and points, your output will be points. The attributes get merged as well as the geography or geometry here. So in my example, I have layer A that has two regions, W and Y, and layer B is the circular region Z. If I intersect, I'm essentially running an AND operation here. So where is layer A and layer B coincident? It's this region up in the corner. So my output are just these two regions, and each one of these smaller regions inherits the attributes of both layer A and layer B. So this region 1 is going to have the attribute W and the attribute Z. Does that make sense? So here we're combining multiple data sets together, both their geometry and attributes, but only where they're coincident. So an example of that would be intersecting a FEMA flood region shown here in light blue in that same area near our central business district. If we intersect that with the streets, that will give us a subset of our data where it's streets that are only coincident with our flood zone. And we're going to combine all of our attributes. So our dialog looks like this. We add all of our input features, and we're going to output and create a new data set as a result. And notice again, our FEMA flood area was a polygon. Our streets were lines. Our output is going to be a line. It's going to be that lowest geometry. The result are shown here in red. Any of these lines that intersected, any of our streets that intersected that flood zone are kept in the output. And our attribute table for each of these streets inherits all of their streets information, as well as the flood zone data. So we're going to take a look at some storm surge data for South Carolina, as well as some schools or airports. And so what we want to do is take a school's data set and intersect it with the storm surge zones to tell us which storm surge zone each one of these schools is within. And then we want to append that storm surge attribute information back to our schools. So we'll use the intersection tool to perform that operation. So that's our question. Let's switch back to ArcMap. I'm going to close my attribute table and clear any selections. And next I'm going to activate my overlay data frame. So I'm going to minimize my extraction data frame here in the table of contents. I'm going to right click on my overlay data frame and click activate near the bottom of the list. So when I do that, it's going to be a whole new map that loads. And if I expand that overlay data frame, I see it has a base map, has a county's data set, these storm surge zones, and their schools. So if I open my storm surge zones attribute table, I'll right click it, click open. I see essentially all the information I have about them other than their length and area is that zone. So it's a code 1 through 5. And if I open my schools attribute table, I can see all the information about the schools here. So an intersection operation will append any of these storm surge zone attributes back onto the schools. It's also going to remove any schools that don't overlap any of our storm surge zones. So I want to run my intersection tool. This is also in my geoprocessing menu here at the top. We'll click geoprocessing, click intersect. And here I can add my input features. So from this drop-down menu, I can grab data sets from the data frame. So I'll first click schools as an input feature, and then storm surge zones. And I need to specify an output feature class. So I want to save it in my results geodatabase, but I'll change the name. Schools, I'll also add storm surge _ intersect. And once I've set those, I can click OK, run the tool. So my tool finished here. I'll click close. And now I'm going to open the attribute table of this newly created layer. And also inspect its location here in the map. So I'll turn off my schools and my storm surge zones layers. And I can see my output does not have any schools far from the coast. So it looks like it did what I expected it to. And if I open that attribute table, I can see all that data from my school, but now I have that zone, that storm surge zone information. Does that work for everyone? No? All right.
So once you do that intersect, you turn off the two.
I turned off the other two layers just so I could see them, see the distribution of my output a little better. Okay, so I'm gonna right click on overlay. Minimize this overlay.
I missed that. I was like, all right, what's down? I looked it up and I was like,
Schools. And then once it finishes, you can go to that. All right. Thinking very hard. So here again, we're combining data and we're only keeping things that are coincident, but we're merging both geometry and the attributes. So we could do this with lines and polygons. We can do it with lines and points. We can do it with points and polygons, with polygons and polygons, and so on. Another type of overlay you can do is a union. And a union is much like a spatial OR operation, where here we're going to keep everything in all of our input layers. What's different about an intersection to a union is that it will only work for polygons. Because with the other geometries, we just don't actually have coincident data. So here we're again going to merge geography and the attributes. But anywhere there's not an overlap in the boundaries, there will be a null value in the output table. So again, I'm going to take layer A and layer B with these zones W, Y, and Z. And then I notice here in region 1, it's only going to have that attribute W. Region 3 adopts both a W from layer A and a Z from layer B. So a union operation is a useful way to combine data that are coincident but may have different scales to one another. And you can, again, merge all the attribute information from these two. So here we have neighborhoods in Philadelphia. And then we also have zip codes. And a zip code covers multiple neighborhoods within the city. So if we wanted to combine these two data sets together to determine which portions of each neighborhood are served under each zip code, we could perform a union to do that operation. So our result would retain all those neighborhood names, but it's also going to break up neighborhoods along zip code boundaries. So here, the Terrace Village is split between the 15219 and 15213 zip codes. And if we identify, use our identify tool, or look at the attribute table, we see that it's going to, again, have a combination of both attribute tables where we have the neighborhood and the zip code information. Oops, I have another typo in my PowerPoint here. We're going to take the county information and we're going to perform a union operation with our storm surge zones. So we're going to see what portions of each county fall within each one of these zones through a union. So I'll switch back to ArcMap. I'm going to switch off my schools layers, turn on my storm surge zones again, close my attribute table. So when I perform a union on these two data sets, I'm going to have, say, Berkeley County here is going to be split up into lots of different polygons for each one of these zones. So to perform the operation, I'll go to the geoprocessing menu, select union. And just like the intersect tool, I'm going to add my input features using this dropdown. I'll grab my storm surge zones and my counties. And I'll save my output feature class in that results geodatabase. And I'll call it, what am I going to call it? Counties underscore surge underscore union. And I'm going to uncheck this box that says gaps allowed. And then click OK and run the tool. This will take a little bit of time to process. Once it does, take a look at the county's attributes, take a look at the storm surge zone attributes, and then inspect the attributes of the output. I might finish too. All right. So let's take a look at these attributes, see what happened. So I'll click close on my dialog here. Open my counties attribute table. And that gave us a name, the state name, population, population density. Open my storm surge zones table. And see that had the zone and some length and area information. If I open my union attribute table, I can see where there were these overlapping features they've now inherited. Both the name of that zone and the zone code. And I have 9,129 records. Here in my output data table. So my union has kept all of my inputs. And anywhere I didn't have an overlap, I'm going to have a null value here in my output table. So again, the union tool is going to work just like an OR for your data. Questions? Let's see, what's next? Let's take a break till 35 after. Everybody can stretch your legs, try running up to Starbucks. Use the restroom just outside the door here. We'll come back in about 10 minutes.
I just watched this later and my friend who's
Another question.
a
Couple times I watched, it was pretty similar. I was trying to do this online to ask students. Do I just use that initial registration? Or are we supposed to, are we not supposed to access it? Or?
You can, it's only to your Clemson credential.
Okay, so I just use my Clemson credentials?
Yeah, so
Okay.
if you get that notification and it prompts you to log in, like if you go to File and Sign in, File, mine's frozen, File, Sign in. You can click Sign in with Enterprise Login. And then you'll type Clemson in the box for our organizational URL is clemson.maps.arcgis.com. Continue, and then click Clemson University. And then you should take you to your normal Clemson sign-on page. And you can just,
Also, script error
you can click yes.
Okay.
Get then your username and password, and that will link your instance of ArcGIS to your user account, and you should have access to Esri subscription services.
Okay.
All right. So feeling good about spatial analysis? All right. Okay, so the next set of tools, we're going to look at proximity analysis tools here. So these look at distances specifically. So we can perform tools that will identify features nearest to some set of features, or it will quantify distances between sets of features. So some examples of that, do we have any roads that pass within 500 meters of a stream? That might be a type of question we would frame. Or what is the nearest or furthest lake from a particular nesting site? Or what is the distance between two breeding areas? We could have more complicated questions if we have a model of a cost for a path, right? Whether that's from slope or some other terrain measure or other things. What's the least cost path to cross some landscape to predict, say, animals' movement? These are all proximity analysis features. And so remember, if we're going to be analyzing and quantifying distance, we want to make sure that our data are in an appropriate projection that preserves distance. So buffers are a very, very common operation here in the GIS. A buffer is a region that's less than or equal to a set distance from another feature. So they could be buffers around points, it could be buffers around linear features, or around polygons. And we can do fixed distance buffers, where we identify the area a set distance all the way from a feature. We can do variable distance buffers. Say major streams have a larger buffer zone than smaller streams, and we link that to some attribute in the table. And we can also do nested or multi-ring buffers that end up looking like concentric circles if we want to buffer different radii around the same location. We can do that. So some examples of why we want a buffer: we can generate areas near schools and say quantify population around each school, or look at how many convenience stores are next to each school to figure out where all the kids are getting their junk food. We can buffer our streets and try to identify, say, homeowners or utilities or bus stops that are within some set distance of that street example. You can buffer around parks and polygons, so to determine areas where you may not want to have developed to preserve, say, minimize sound coming into a national park, for instance, and not have developments, or say a rifle range next to your national forest. Lots of examples here. Analyze flooding zones or buffer around them. So what we're going to do is we're going to buffer some of our storm surge zones. So we're going to find areas that are within 250 meters of a Category 3 storm surge zone, and then identify which bridges are within those locations. So we may have an engineer contacting us, or a city department or county department official asking us, what are the bridges that might be impacted in a Category 3 plus a little bit? We need to go inspect those and make sure that they can handle an upcoming storm, for instance. So we're going to buffer our storm surge zones to identify these bridges and take a look at those buffers. So let's switch back to ArcMap. I'm going to minimize the data frame from my overlay data frame, and then right-click my proximity data frame and then click Activate. And then I'll expand that data frame. I can see my bridges are showing up in points here and my storm surge zones as they were before. So if I'm going to buffer, where is the buffer tool probably going to be located? Ideas? Geoprocessing menu, yep. I'll go to my geoprocessing menu. It's the first one to buffer. And so I'll go to my input features to the drop down. My input features are going to be storm surge zones. But I'm going to pause for a second and think, what areas did we want to buffer? Did we want to buffer all of our storm surge zones?
Yeah, really more.
Just the Category 3 storm surge zones. So do you all remember last week when we did tabular queries? I pointed out that a selection in a data set I should say this, geoprocessing tools often run just on a selection of a data set if it's there. So if we select just our Category 3 storm surge zones from that feature class and then buffer our output, we'll only buffer the selected zones. So how do I want to select just these Category 3 areas? How can we do it? Say it again. Select by attributes. All right. And then what? So we'll select from our storm surge zones layer here at the top. And we want just where zone, so I'll double click zone, click equals, click get unique values, and then double click 3, and then click on verify. It says it was successfully verified. If I click apply, click OK, I want to zoom in and take a look. It looks good to me. I see that this orange zone is selected, but not this yellow or green one. Yeah. Valid statement.
Oh, I can do that one. Okay. Sorry.
That's all right. Got it.
I think I did.
Yeah, looks good. All right. So now that we've set that selection, let's go back to our buffer tool. So my output is going to be a new feature class. And I'll save it here in my results geodatabase, and I'll call this zone_3_buffer. We can set a linear unit here. Right, this is the distance we're actually going to buffer. So ours in this example would be 250 meters. So I'll set my units to meters, type 250 in the box. And here near the bottom is the dissolve type. I'm going to select dissolve all and not none. So my dissolve type I'll set to all. And then click OK. Once it finishes, I'll pull up the schematic here, or maybe I can pull it up in the internet. So when we set our output here, we can not dissolve our output, which means that every input feature is going to have a buffer polygon created for it. So there will be an equal number of polygons in my output as in my input. If I dissolve, it will merge any overlapping buffers into one polygon. So here we'll just have fewer outputs or fewer polygons in our output. There may be some circumstances where you want them to be separate, and there may be some where dissolving is appropriate. And I'm going to not click on anything for a minute while it thinks. It seems to be freezing up for me. So something I'll point out is we're working with fairly heavy vector data set. There's lots of vertices in these data. There's lots of features. And processing on them is pretty slow, even on very powerful computers. Vector data are fairly sophisticated to model in a computer. Rasters are easy, right? It's just a grid of numbers. And computers love calculating things on grids of numbers because it just goes through very quickly. Here, it needs to evaluate lots of different things that a raster doesn't need. So next week, we'll see when we do some raster processing. It may still take a while, but it's much more efficient computationally. So I am 33%. Oh, there it goes. Okay. So I'll click on close. Close my dialog here, and now take a look at the output. So here I see it's dissolved, right? It's merged together all these overlapping buffers in the from that data set. So now, what was the question I was trying to answer? What problem was I trying to solve with this buffer? So which bridges in my data set are within those areas? So based on what you know so far, how can we answer that question? What step can we do next? An intersect? Yep, we can do that. So an intersect, we would intersect our highway or our bridges layer and our buffer layer, and then our output would be points, and it would have some combination of those attributes in the result. Is there another way we could do it? Anyway. There's one other way. So there's something else we've done already that we could try as well. A union, those both needed to be polygon layers. Yep, we could intersect them, or What else have we done? We clipped, we intersected, we unioned, we buffered. What else? What was the other thing we've done? We could select by location. Yep, there we go. So we could also use the select by location and say, select those that intersect between the two. Right, so what would the difference be in those two methods? What would our differences be in our output? And what would be the result of each operation? If we do a select by location, it will give us what? Selected points in the pre-existing data set. If we do an intersection, what will it give us? A new data set. Yep. With again, that merging of the attributes. So here, we just want to know which bridges they are. We don't know if more data is needed in that attribute table or not. So I won't say one is a better way than the other. But depending on what you need out of that operation, one may be a better example or a better choice. So if you want to do an intersection, go for it. If you want to do a select by location, go for it. And then we can compare the results. How's that sound? So everybody try it on your own, either intersect or select by location, and try to identify these bridges. How many people have a result? About half. And which way did you go? You did both? And select by location? Select by location. Intersect? Location. Good, thanks. How many did you get as a result? Did everybody get 514? That's what you would expect, right? I mean, we're doing the same operation different ways, but you would expect to have a very similar output. We said no. How many did you get? 742. 742. And you did. People want to do select features from. Clear to free select feature. I did it both ways myself. I got 514 points output from the intersection. I got 514 from my select by location. Okay. So did you use the location? Location. So we wanted to clear first selection of select features from. Select features from. You said how within within a half a mile. That'll be okay, so here we've used our buffers to identify regions that are a set distance here from, in this example, our category 3 storm surge zones. And now we know we need to go out and worry about 514 bridges here in South Carolina. So the next tools we'll take a look at the point distance and nearest features tools. So a point distance works just on points. And what it does is it calculates the distances from each point in one data set to each point in another data set and then outputs that to a table. The near tool is similar, except it can work on points, lines, and polygons. Here, it will tell you the ID of a feature nearest to an input, and it will also tell you that distance. So for example, this point 1, its nearest lake is lake 1, same for lake 2, but it outputs the difference, the distance, and here lake 2 is slightly, lake 1 is slightly closer to point 2. So what we'll do is quantify distances using that near tool. We want to find out how far each hurricane relief center is from a major highway. So on average, how far is a hurricane center from a highway? And what are the minimum and maximum distances in there? Or what's the statistical distribution? So this way we can get a sense for the response time or travel time to a particular shelter from a highway. So switching back to the map here, I'll clear any selections I have in the map. I'll clear those selected features. I'll turn off my bridges layers and my storm surge zones. And I need to add my highways SC layer that I output. Close my attribute table as well, but I'll go to my results geodatabase, drag and drop my highways SC feature class into the data frame. And I'll turn my hurricane shelters back on. Turn off my buffers. So the near tool is not here in our geoprocessing menu. It's somewhere in the ARC toolbox. So to find it, I'm going to hit Control and F on the keyboard. And that should open the search menu. You can also click here near the top next to that ARC catalog button to open the search bar. And then we can just type near in the box and hit enter. And the one we want is this near analysis tool. So our input features in this example are going to be our hurricane shelters. And our near features are going to be the highways SC layer. And once we've set those, you can click OK and run the tool. And so it's going to append all the information from the tool back to your input features attribute table. So for us, that'll be our hurricane shelters. If I right click my hurricane shelters, open the attribute table, it's added 2 fields to that table, the near FID and the near distance tools, or fields here. So that distance is going to be in the units of my projection. So these are all meters. So our first question was, how far on average is a hurricane relief shelter from a major highway? 611. Where did you go to find that? Right clicked on the near distances field, click the statistics, and I get my mean 611. Yep, 611 meters. So the minimum I get 0.85, right? Some hurricane shelter is right at a major highway, and a maximum over 5 kilometers. So just to help you interpret this output, the near FID field gives you the FID or the feature ID of the closest feature from our other data set. So if I open my highways SC attribute table, notice this object ID field that's automatically generated. That near FID field is going to tell me which one of these is the nearest. So what I'm going to do is just highlight from my hurricane shelters table this first entry by clicking this small gray box on the left side and select that one shelter. Then I'll right click and click on zoom to select it. So here is my selected hurricane shelter. So just by looking at the map, I would guess that my nearest feature is going to be this road just to the east of it. If I use my identify tool and then click on that feature to pop up some information, I see the object ID is 1907. Am I reading that right? 1507, sorry. If I go back to my attribute table here, I see my near FID for that entry is 1507. So if it's important to know in your output specifically which feature is the nearest, this links the 2 data sets together. Does that make sense? All right. So that's our near tool. Now I know for every one of these shelters how far it is to a major highway. There's this one that's 2 meters. Yep, it's right on it. Okay.
Those 288, those are the total number of hurricane shelters in the state.
Yes. At least in this data set from 2016, I think. All right. So the next class of analysis tools we're going to look at are a spatial join. So last workshop, we talked about tabular joins, where we appended attributes from one table to another by linking some common field between those 2. We can also join attributes from one feature to another based on their location. So much like a select by location had these different spatial relationships like intersection, containment, or proximity, we can join features from one data set to another based on these relationships. So the way in which it appends is going to depend on the cardinality of that relationship. Right, so if we have a one-to-many relationship, we can join or grab attributes from one feature and append them directly to another. So for instance, in this middle containment zone, we could append the attributes of the polygon to each of those points because it's a one-to-many relationship. If we go the other way and try to append information from the points to the polygon, we have to summarize because it's not the appropriate cardinality. So we'd either take the mean or some other statistical measure of the two, just like we saw with tabular joins. But to demonstrate that idea, again, if we have a many-to-one relationship, it works just like we would have for a tabular join, where here we want to append habitat information shown in the polygons to our animal locations represented by the points. Because it's a many-to-one relationship, we can just repeat all that attribute data from the habitat to every one of our animals. And this is also a containment relationship. If we go the other way, if we try to append the animal locations back to the habitats, the relationship isn't clear which one of these they should adopt. We need to summarize over all of these points and then append that summary back to the polygon. Does that make sense? If we look at it another way, using distance, we can join using, say, points that are near streams. If we have a many-to-one relationship, say our septic tanks, we could join the stream information from the nearest feature back to each one of those septic tanks. If we try the other one, joining septic tank data back to the stream, again, we have to summarize. So there's a lot of different cardinalities or relationships we can look at based on different geographies and lots of examples of those. Continuing our example, let's say we have a point feature class containing schools and we have polygons with counties in them, and we want to know which county each of these schools belongs to. We would join that county information to our schools. Right? It's a many-to-one relationship, and our tool looks like this. So we would right-click our layer, select joins and relates and join. And here we join data from another layer on spatial location rather than from a table. And here we select how we want to join those. So for instance, grab the attributes from the polygon. Each one of these schools falls inside. Notice here at the bottom that you have to output a new data set as a result of a spatial join. It's not like a tabular join, which is dynamic and lives in the map document. This will always create a new data set. The reverse operation, a one-to-many relationship, would be joining the schools back to the county. And so here we would have, we're going to summarize that information. So we could either take the sum of the number of schools or some other measure. But again, our output will be a new shapefile or feature class. We can do this both with containment and with proximity, so we can summarize attributes from features that are closest to it. So here we could figure out for each one of these schools which park is nearest to it and join those attributes back to it. Excuse me. So we can use different, we could also look at overlay, right, and grab all those attributes from the polygon that falls inside. For our exercise, we're just going to look at some of these storm surge zones again and look at airports. We want to know which storm surge category each one of the airports falls within. So we could do a spatial join to get that information. So I'll go back to ArcMap here. And I'm going to minimize my proximity data frame and then maximize my spatial join data frame and right-click that spatial join data frame and activate it. I'll close this attribute table here. So here I can see I have airports that are symbolized for how busy they are And I see several of these are down on the coast and fall within various storm surge zones. And I want to join those storm surge zone codes back to my airports. So if I want to perform a join, where do I want to go to do it? I click where? Right. So in this case, that would be which one? Airports. Yep. So we'll right click our airports. Hover my mouse on joins and relates, click join. And we're going to join data from another layer based on spatial location here at the top. The layer we'll do is storm surge zones, and each point will be given all of the attributes of the polygon that it falls inside. And so the result will be saved in a new layer. We'll save it in our results geodatabase, and we'll not call it join output, which is a terrible name. We'll call it airports _ surge zones. Click OK to run the operation. And that new data set gets added to the map automatically. So how many of these airports are within a category 3 storm surge zone? Question or are you answering?
No, answer.
Okay. How many did you get?
I think 2.
2? Agree or disagree? Agree? So I also see 2 of them. I see the Hilton Head Airport, the Mount Pleasant Regional Fison Field Airport. So to help me out, I sorted my zone field. I right-clicked it, said sort to sending. I can also see the Beaufort and Grand Strand airports are within category 5. Charleston Executive, Beaufort County are within 2. That was our spatial join questions. All right. And here's what I have left. I have homework for you that you can work on. The idea was to give you a problem to work on with the rest of the time here, to give you a chance to try these things out for yourself, to think through solving a problem, exploring data, creating a map layout, all these skills where you can have a chance here to ask me questions, get help without having to struggle through on your own, or 3 months from now when you use the software on your own, try to remember how to do this. It's a good chance for you to solve our question. So here's my hypothetical problem for you. We're trying to find habitat for our Clemson tiger bird. This funny creature seen here. It was gone for a long time. People started seeing it again when we won the national championships year before this one. The thing is, this bird has very particular nesting habits. It's scared of people. It likes living in evergreen forests. It likes evergreen tree cover. It likes to be near water. Generally find nests within 50 meters of a stream. And it does not like noise, especially not roads. So it tends to be further away from roads. So biologists want to go and find this animal. They want to try to count the number of nests or potentially tag these birds. They need to know where are the areas to send all their grad students out to try and find this thing. So what we have are some different data sets. We have a land cover data set. The NLCD Upstate Poly. NLCD is the National Land Cover Database. That tells you what type of, say, forest you have or if it's developed. We have a watershed boundary. We're only interested in looking in the Saluda River Basin. That's going to be our first area of interest. We also have a feature class containing streams in the Saluda Basin, and we have road data for all of South Carolina. So what the people would want from you is a map that says, here are those locations that meet all these criteria. Your goal is to use these data to find those locations and put them into a map. So if I open Art Catalog again and just preview our data here, what I'd like you to do, it's entirely optional, of course, but I'd like you to just try and attempt to solve this problem on your own. Ask each other for help, ask me for help, but work through the steps and try to perform this analysis. The bird is obviously fake, or is it? But this type of analysis is a fairly realistic one. So I'll wait for Art Catalog to open again. Let's preview our data a bit. And so you know everything you need to know to solve this. There are some tips and tricks I can show you that make it easier.
Well, if things didn't go right for you in the last few exercises, can I ask you a couple questions about that before I start working on that?
Sure. Yeah, just wanted to make myself available to you. I'm gonna just preview the data for a couple minutes. We'll take a look at it and then I'll wander around and answer questions. All right, so if I take a look at a spatial analysis problem geodatabase, come on. Okay, here's my NLCD upstate poly layer. So you can see a pretty heavy data set, lots and lots of features taking a very long time to load. But if I look at the table, within that table is a land cover attribute. So I see things like developed open space, mixed forest, evergreen forest, deciduous forest, and so on. So I'm interested in those evergreen forest regions for my tiger bird. The Saluda Basin boundary tells me where the Saluda watershed is, or my area of interest. I have all the roads for South Carolina, again, fairly heavy data set. And then I also have the streams within the Saluda Basin only. So what I would like to see in my map is going to be snippets of the forest. So these forest polygons, but only those that are within 50 meters of one of these stream lines and more than 200 meters away from our roads. So those are the data you can use to solve the problem. I leave it to you to try and solve it. So time is yours. One. And as I can. Questions or others?
I was just curious, you have the same results here as you were saying, but I didn't understand saying that when you were in two or one storm surge zones. To me, or was the question, which ones rather than
I actually chose
zone three? Okay.
So it's just those ones, right, where there's no overlap.
Gotcha. Okay. Okay, I thought you were talking about all. Okay, and then I tried it a few different ways and I could not get the bridges within the search areas and I never came up.
Okay. So what accurate proximity data from the table?
Okay, I have a question. That activate, do you activate or is it using
No, only one can be active at a
only
time.
one for the things? Alright, it has always the case on the data sets active. Okay, what did I do? Because I should clear the features.
Yeah, so if you expand the proximity data, so you got the zone 3 buffer using that. Those are good. So which way did you try this?
I have selection by location.
Okay.
I have to admit, depending on how I think about it, I'm not totally clear on which, conceptually, the difference between the target and the source, but when I flipped and I did them each way, I still.
Okay. So the target, this is the layer you want to select features from.
Okay, so I want
So you want to select the bridges.
Okay. And,
And there at the top though, select from the currently selected features.
and,
We want to just select features.
okay, maybe that
We
was what I
don't
was
have a
saying.
current.
I don't have a current selection. That might have been my, and I'm looking at buffer, and I don't need distance because I want, okay, and then my other question is, we're hearing about points and polygons, what's the difference between intersecting and
If you're looking at points and polygons,
okay, so those are feature changes.
they're effectively the same.
The same, okay, because mine is.
Lines and polygons can be a different story.
Right.
Does this just intersect the boundary or not? For points,
Either or, so there's not a, like, I noticed you kept going to intersect, so I was just wondering, conceptually, is there?
conceptually, no, I just get better results for some reason. Sometimes are within just those in here.
occasionally the cloud is, well, there's gaps or holes within fields, right? So that it's not there at all.
Potentially.
Potentially, so that could be a contaminant there. There's just like, I was just trying to understand.
Yeah, so conceptually they wouldn't be the same.
Okay, so I've done this for bridges, this is my source, it's from, I have to evaluate distance. Does it have to apply?
It'll calculate twice if you click apply and
That's
that's.
right.
So if you click
So I
okay.
just understand what my optimum was like, me trying. That was it.
So I think what you did was select from currently selected features.
I kept getting zero. I was wondering why. Okay, that's it, thank you.
Well, I was basically trying to select. So, maybe I was looking at that.
Yeah, so remember, like is a wildcard operator, what you wanted was equal to. You wanted it to be exactly.
Oh, I tried that. That's where it started.
Click OK, and then just delete that whole statement. Double click the blank cover. Equals, and click get new values. But we want to just select everything before.
Oh, so there's a, I'm wondering if it's because I have double quotes.
That,
That's probably what it was. Instead of-
yeah,
Our regular seat was, we can't. Well, it depends. on the
GIS.
SQL editor you're using, yeah, a lot of. I don't care. All right, cool. I'll work on this. Question on the.
Will we go over workshop how to,
Or should I know this from, like how to essentially buffer only, and then get like the average? Or like calculate it. So ultimately what I'm going to want a length stream.
Right. We won't do that exactly. Summarize within or zonal statistics, depending on whether you're trying to summarize vector or vector data. Summarize within will summarize vector data within some polygon.
So we'll have to create a new polygons and everything.
So in your case, if you have points in the buffer now, and you want to get the area of just land covered, your input would be the buffer, you're going to get this out of the land cover. So that one is more vector data. Zonal statistics, if you're trying to analyze a raster within, so if you have, say, a slope raster or something. So we may get to zonal statistics next week. Probably not.
And then we can get, have a buffer.
You have a buffer and let's say like an elevation raster, calculate the slope from, you want an average slope within that buffer. Zonal statistics.
And then if I were, that's even that.
Yeah, should be dangerous enough to do it on your.
yeah, and it's nice having this, because I'm pretty much every hand.
So
bars. I mean, like, Googling things and trying to get them.
Over time, you get better.
But there's so many like bookmarks or like so many things.
So far? Alright. I see how quickly I can solve my own problem. to make this work. You can either tell me and I'll write it, or feel free to go write it.
How would you solve the problem? What would you? What are people trying so far?
So my first step was to find the cellular basin boundary and then to mark my territory. And then I wanted to have the attribute evergreen forest because I know they only live in the evergreen forest.
Right. So you did some sort of selection with the attributes on that?
Yeah.
So we have our NLC.
So first I clicked the territory so that I have the boundaries. And then I use select by attribute. Yeah, I used the area I clicked earlier, and then my method was create a new selection, and then cover equals evergreen forest.
So the output of these is going to just give you evergreen in the basin. Right? Okay.
And then the next step would be to find all the rivers and then have a buffer around the rivers of 50 meters.
Yep.
Yeah, that's just like it.
Okay, and then what?
And then you have to make a second selection, and it would be a buffer zone around the roads.
Okay.
200 meters. And then just deselect it.
So when you say deselect,
Yeah, I'm not quite sure how to do it. But just logic.
other ideas?
Could you create an intersection between the basin boundary and the upstate valley?
Yep.
Then, from that, select only there. And then do the buffers
Do the buffers
on the streams. Like, so far close.
yeah, those orders would be interchangeable.
So, I'm not able to, I'm trying to get them to change it.
It's a big data set.
It's, well, it's still sitting on it. So I first clicked all of them to be just this little basin. And then I did the select evergreen, buffer the streams, and then trying to do an intersect with the two. And from there, I would do a meter, rows, and then sort by that distance, and select only those that are. But I haven't. It's my understanding.
Okay. Okay, so you were saying that intersect. And that would give us evergreen near streams. These are going to be polygons, but let's call them evergreen near the streams. And then you said run the near tool. So near on the roads,
Yes.
using the roads.
Wait, what?
So when you said you were going to run the near tool, you were going to
Mhm.
use this and then the rows, is that right?
Yes,
So
but I think I'm wrong.
for the rows, whoops, that over here. And that would output the nearest road and you could see which one.
Yeah, but I don't think that's
That might work. That's an interesting way to approach
But the
it.
near with polygons would just give the whole polygon is near to the road, so half the polygon could be appropriate. Right.
So it's going to look at all around the polygon and find the nearest road.
Right.
So any of them that the nearest road is greater than 200 meters, that may work.
But if you have a greater than 200-meter polygon,
From the edge of the polygon, not the center.
yeah. So what I'm saying is, if your polygon is big enough that at the edge, it's within 200 meters, but at the center, it's larger, it's farther, you have habitat at the center of that stream evergreen area, but it's gonna say the whole polygon. Not clickable, because it's measuring from.
I think I know what you're getting at. I don't know if that would make a difference here. That's interesting though. The way I would maybe approach it is do these, get my evergreens near the streams, do a select by location, and find those that are within less than 200 meters from a road. And then from the attribute table, you can invert a selection. And that will give you all those that are more than 200 meters from a road. Which is very similar to what this is doing. You could also buffer the roads 200 meters. And then there's a tool called Erase. This is one that we didn't get to today, but use it to erase these features here. And that would remove any part of the evergreen forest near the streams within 200 meters of a road. And that's what I was trying to do up here. It looks like it's finished. So let's take a look at it. Yeah, here we go. So that's what I did here. I intersected my evergreens with a buffer around the streams. I buffered the roads 200 meters and then used the erase tool to erase out those buffers. So if I inspect my results, I'm going to change a couple of, I'll change my roads to this symbol, my streams to something that looks like a stream to me, my evergreen forest to a dark green. My output here all look like they're near a stream, and if I turn my buffer on, I see they're all at least that far from the road. So here's all my potential habitat in the basin. Looks like these biologists have a lot of work on their hands. But this is a pretty big area. If I grab, say, the county, or sorry, the state outline, you know, that's almost halfway across the state. So it's a fairly large region we're considering here. You can just leave it. That's the default. Okay.
Flipped. Or not, just from here. But all of these and turn this on. And it's not there. There's no data. No one wants to see this.
See you next week.
I think a couple of you were saved to different June databases. There's like either one, but it's all of them, they're all of you. That's my master's, I got a prescribed birth life. they're already default.
So I didn't select.
I think that looks like half the roads that but this has nothing in it. Yeah, that's just. This is what I always do. I don't really know what I'm doing. Next one. This one is the same.
You're welcome. See you next time.
Yeah.
Oh, shoot. Fast forward. Yeah, feel free to stay and work a little longer if you want, or I'll release you. Is this time useful to everyone? You feel a little more confident in trying to do things in GIS, performing analysis, working with data? It's helpful. That's how to do experiment. I did that more. Looks like something. I don't know why.
Oh. What would it be next? She would do these with our next. Oh my God. I must have full to try to apply it.
See it?
So I buffered the roads and then I used it to erase the street intersection.
Sorry.
Erase analysis.
Is there a way to isolate the evergreens within?
So you selected just the evergreen.
Just like evergreen and there's so many, there's thousands of. And I sorted it by evergreen, that was like just evergreen. Within all land use.
Okay.
There's barren land,
Yeah,
there's
so
deciduous forest, there's
let's
mixed
clear
forest.
this selection. Let's do an attribute selection.
Okay.
So here, select attribute. That's all right. And then select the attributes, and then we want land cover equals remaining forest.
Okay.
Double click, so we need to erase that. Double click land cover equals, and then getting values. This will take a few seconds.
So I'll load from, let's find out.
Yep. Okay. Evergreen forest. Double click it.
Okay.
Apply. So now you've got just those evergreen forest options.
Okay, and does this select that attribute because when it's on its own layer and then I can deselect the rest of the attributes within it there?
Okay. What if your goal, what's your next step? Identify just those boundaries.
Excellent.
So,
Yeah.
but I guess I'm not sure if I've identified just the other. So, in the past when we've done joins, intersections, whatever, there's an output layer that's automatically generated, and we just deselect the source so that But there's nothing, I mean, this isn't selecting my attributes, not exactly the same process. How do I know that?
So
Okay,
you shows just our select.
okay.
So here, you can see it's selected 55,000 of them.
Okay.
You could export these data to a new feed.
Okay, but I'm not showing, I know I'm not showing bearing line, because I mean, I still have that whole clip selected. But I just know that within that clip, I've already done a selection.
Yeah, so now let's we want to go to data and export data. Let's just export to your own feed. So it
Do I
will only
need to
be
deselect other things, or just highlighting it on this? Okay, export selected features, sample list, okay.
and then output. Let's browse to just the default. Let's go up to the look in and go to the folder pane. Save in spatial analysis. We can save it. Let's give it a new name, maybe Evergreen Forest Basin.
Okay, no space, Okay.
Turn this off.
Okay.
Now we've got our roads that are clipped. Now we have just those evergreen forests in the basin. We have our buffers from the stream, so we're pretty close.
Yeah, I haven't perfected the roads yet. Yeah, I have to get, some instruction on, I don't know if it's going to just this. For that erase function, I have to do.
Sure.
Okay, so, buffering.
So the buffer with the
Was it
roads.
geospatial?
Yes. Let's grab it, saving it in that default view.
Oh, did you, okay. No, we go back up to.
We'll double click on
Buffer,
it to go
oh,
over
okay,
to-
thank you. Roads, and then.
Set our distance.
It's 200 meters, and we can dissolve these.
Yeah, that's fine. That's it.
I get.
And once that finishes, there's the erase tool. You can search for that one. It's from the analysis tool set. Erase. No. Also, yeah. So I would export them to your own feature class. So you don't have all the other boundaries. So by and then right click here and then see the upstate polygon. Go to data and export data.
Erase coverage or erase
Export
coverage?
selected features. Source. So I would So this will just, for only those evergreen polygons. So from there, you can buffer your streams, you roads, streams, intersect to and then
You have more than one feature, and which one is your, race analysis or race features?
analysis.
And
So your input is going to be your cookie dough. Your arrays is going to be what you want to
my
try
cookie
out.
dough's got a bunch of ingredients in it.
Just one.
Just, it's just the streams, because it's within
So-
the streams.
So what we're trying to do with this one, let's say,
Within 50 mil.
did you
the
enter?
stream.
So you could find, let's say this is
I
my,
have to join, I have to intersect my streams, my buffer streams and my evergreen.
at some point.
Should I do that
I think
now?
that could be second one.
Should I
So
do that
if this is
now?
my evergreen and this is my buffered road, the erase tool would remove these sections and then my output would just have this.
So it doesn't really matter to see.
If I had, right, if then I had my stream buffer that was like this,
Mhm.
and I intersected, it would only output that zone.
Okay, so it doesn't really matter to see ones. Okay.
In this case, no.